Alright, so this is going to be your Unit 1 review. I'm going to try to point out some things to you here. So what I've done is I've uploaded all of the review sheets for the whole chapter. Now what you can do, and I'm recording my screen here, if you go to the Tiffin State Schools webpage and you go to the online classroom and you click on Unit 1 Biochemistry, Nature of Science, you're going to get a folder that comes up. So here's all the present me's. You can see them right here. So the PDF here, oops, I don't want that. These right here are the PDFs of the lecture. But what you want is down here where it says what to know. And what I would encourage you to do is click on that. Click on what to know. And when you scroll down on that, you're going to come to all of these worksheets. So water, carbon, and carbs is the first one. Lipids, proteins, nucleic acids is the second one. So if you're wondering where are all these worksheets at, they're there for you. So let me close that. So chapter 1, or exactly chapter 2, basically what you need to look over is hopefully you understand this whole idea of made of elements. Again, I'm not going to expect you should hopefully remember CHON, carbon, hydrogen, oxygen, and nitrogen. That's the big thing there when we talk about this section are those four main elements. We won't get too much into trace, hopefully the proton, the neutron, electron, and hopefully remember that the one that we're most focused on there is our buddy the electron. Remember it can have 2 in the first orbital, and then as far as we're concerned, we're looking at 8. And so that's your whole idea of the valence electrons. We're not going to get too much in periodic table. There's your atomic number. Don't worry about that. Elements of current nature. Hopefully you do look over this term. Isotopes. Hopefully you know what those are by now. But again, as the same number of protons, different number of neutrons. So I'd look over that. Energy levels. Again, we're not too worried about the orbitals. But again, like I said previously, please focus on this whole 8 electron idea, that octet rule, because that's really important for it to be a happy little molecule. It has to have 8 electrons. So, and again, key here, as we've already seen on our one quiz, the chemical behavior depends on the number of electrons in the outermost shell. Those are your valence, and that'll determine if it's ionic or covalent. So those are the kind of things you should look over from chapter 2. There's the whole idea of molecules and compounds. I think we know that. I think we're right on chemical formulas. All right. Hopefully you understand now what a covalent bond is. They share electrons. I think we're good on polar and non-polar. Again, looking here at oxygen, has that negative charge. These hydrogen's got the positive. So if I were to add a molecule here, it'd be an oxygen because oxygen has that negative charge. Hydrogen has the positive, and then so on and so forth. Non-polar we've talked about. I think all of you did pretty well on the quiz with that one. I think we're good on that. I think we understand ionic bonds. Sodium chloride, if I were to throw this in water, hopefully you see the sodium would bond with the oxygen. Chloride would bind with the hydrogens, which we've already seen. Hydrogen bonds, these are weak attractions between molecules, which we've talked about. So I think I'm going to check that one off because I think we're good on that. Water molecule there. There's our van der Waals, ever-changing positive and negative hotspots. And then here's our relative strength, going from strongest to weakest. Now it's hydrogen bond, depending on what you learn in chemistry. If it's a hydrogen bond, it can be pretty weak. If you look over here at this picture, hydrogen bond here, but within here, the actual water molecule, that is a covalent. Sorry about my handwriting, but this is easy to do. Chemical reactions. I'm not getting into oxidation reductions in this test, so we will come back to these a little bit later. So all of this stuff we're not going to worry about right now. Alright, so we can skip that. Equilibrium. Again, I still have people missing this on the test. So when we look at equilibrium here, formation of products equals the rate of breakdown on products. Products and reactants are continually being formed. All right, there's no net change, and so again, I'm not sure why we keep missing that. Water molecule, carbon molecules, similar functions, I think. Okay, I did ask about this one. Remember, morphine, heroin, other opiate drugs, similar shape, so they can bind to the same receptors, similar structure, similar function. Same thing with endorphins, binding receptors, brain effects, euphoria, and release pain. Opiates mimic these natural endorphins. That's chapter 2. So what you need to go through that review sheet so you can understand. Chapter 3, that's all the water. And so one of your essay questions will come from water. And again, if you don't watch the review, you won't know that. Hopefully by now you are familiar with this structure here. Polar covalent we've talked about. We know it's a covalent bond. We should know what polar is by now. We scroll down. All right, you need to know these properties of water. I'm going to circle that because that's going to probably be your essay. You got to list those properties of water and why they're important. And there's going to be some questions on there about that. Hydrogen bonds, I don't think I have to go with that. They can form 4 hydrogen bonds with 4 of the water molecules. So 1 here, 1 here, 1 here, and 1 here. So there's an argument 1, 2, 3, and 4. Very strong response from emergent properties. All right. And sorry, Peyton, water is the universal solvent. Likes dissolve likes. We talked about that. Provides medium. Hope you know what solution, a solvent, and a solute is. Hydrophilic and hydrophobic, I think you guys know. Oil and water don't mix because of interaction. Phos 3 structure. Empathetic molecules of both polar and nonpolar regions. We didn't talk about that much, but detergents and phospholipids, when we talked about the phospholipid bilayer, that's empathetic. Cohesion is another one of those properties. So water molecules stick to each other due to hydrogen bonding. There's your surface tension, not surface detention. Adhesion we talked about, the meniscus and graduated cylinder, capillary action, cohesion of water molecules, and adhesion. So this has both properties there. Density, I think a lot of you have this one confused. So the density of liquid increases, temperature goes down, so most substances are more dense. Ice is less dense than liquid water. One of the few substances where that's the case. Insulation, so this is why it's important. Insulation. Lake freezes top down, allows anything to survive in the winter. When we talk about heat, temperature, measure, edge, connect, we did that energy, all right. High specific heat, this is another emergent property, I think we're good on that. Liquid water can absorb large amounts of heat with small temperature changes. Allows for homeostasis. I think we're right in that. I think you guys understand this vaporization. A lot of energy to convert water into vapor. Evaporation of water produces cooling effect. Evaporating cooling. I was going through the main points here. pH scale. Most of you did really well in the quiz, so I'm not too concerned about the pH scale. However, you've got this, I think most of you understand this. pH negative log of 10, so if the hydrogens, pH is 7. So if we look here, you add them up, you get 14. So 10 negative 9th, OH is 10 to the 5th, that gives you 14. This dissociation, some of you missed, basically water dissociates or comes apart and forms these ions. So here's water, this is when it dissociates, right here. Alright? And so that's called the ionization of water. It breaks up into H plus and the OH. And again, some of you missed that for some reason. Not sure why. Alright, let's get this buffering system because I will have some questions on there about this buffering system. So, carbonic acid. Buffers are weak acids or weak bases that act by... That's not very good. Balance it out, minimize change of concentration. Some act as reservoirs. We condone that. Some can donate and some can remove. And they maintain homeostasis. Now, the bicarbonate buffer system in blood. Again, I'm having some issues with drawing on this. Maintains blood between 7.38 7.42. H3O is your weak base. H2CO3 is your weak acid. So When in equilibrium, water plus carbon dioxide, this is going to be important. When water reacts with carbon dioxide, it's going to form carbonic acid. All right? And then it can dissociate into bicarbonate and H pluses. So the action there is strenuous exercise, all right? Strenuous exercise, fatty acid metabolism, acidic overdose on aspirin. It's going to increase the H pluses, which is going to decrease our pH. Remember, decreasing pH, becoming more acidic. Or if you hyperventilate, you remove CO2. So the buffer's response is the equilibrium shifts to the left. So H2O plus CO2 will give us our carbonic acid, and then that carbonic acid will release these hydrogens here, and you're left with bicarbonate. Some of you got it, some of you don't yet. Body organs help maintain balance too. Brain signals lungs to breathe more deeply and slowly. Remove CO2 to raise pH. Kidneys remove the HCO3. If we go back up here, just so you remember, our HCO3 are bicarbonate, causes shift to the right. If someone's hyperventilating, they breathe in a paper bag because it increases CO2 and shifts equilibrium to right. And treatment for acidosis, patient is given bicarbonate. You need to know this bicarbonate. All right. Now, the last slide I think I have here, though, is this. And you're going to have a question about this, so let me kind of make sure you guys can see that picture. And again, I think you can download this. So what's going to happen here is CO2. So we got CO2 in the atmosphere, and I'm looking off my notes here off to the side. So we got CO2 in the atmosphere. It dissolves. So this CO2 goes here. These two are going to react, and it's going to form H2CO3, which is going to form carbonic acid. So we got a weak acid here. All right? So this occurs, we got a weak acid. So far, so good. Now, our weak acid, all right, our carbonic acid dissociates now into H plus and our bicarbonate. Well, if we got this H plus, it's going to cause a decrease on the pH scale, which is essentially going to cause water to become acidic. So we've got our carbonic acid. It dissociates into H pluses and bicarbonate. Now we've got these H pluses here. All right. The added H plus combines with CO3, which is carbonate ions, forming more HCO3. Okay. Now what happens is the fact that these two are combining, I'm going to circle that, these two combine, this means that there is less carbon available for calcification. Less carbon for calcification. Less carbon for calcification. So what happens is if there's less carbohydrates for calcification, that means that there's less calcium carbonate for things like coral, less carbonate for coral to build their shells, to build their basically their exoskeleton. Less calcium carbonate, less exoskeleton, less coral. So the fact that we have this increase of CO2 leads to a decrease in coral because of this whole process here. So hope that made sense. And if it's something you don't understand, we'll review it. I'm going to have to stop here. I will pick up chapter 4 in the next slide because I'm out of time. So again, this is your first review. Good luck.